announcements of other upcoming events. Next Wednesday in the evening, right here in the Harriman Atrium, we have a screening of the film Dolbush, which is all the rage in Ukraine now. Everybody's talking about it, and we're going to have it right here for the Ukrainian Film Club at Columbia University. Andryczyk will be leading that event, so please come to that. And on Thursday, a week from today, we have a conference that is packaged together with today's event because they both deal with the Holodomor, the man-made famine genocide in Ukraine. And the conference is going to be entitled The Assault on Culture in Ukraine, the Holodomor Years, where we'll look at how, in addition to starvation of the populace, there was an attack on wiping out Ukrainian identity by stifling its culture. And just like it was successful to a very large part in doing that and stopping the whole explosion of Ukrainian culture, which had and still has to this day effects on Ukrainian society and Russification and erasing of the Ukrainian identity, which just recently, decade or so, Ukraine is dealing with. Today's event also deals with the Holodomor and its effects on today's Ukraine. The title of today's event is The Long-Term Impact of Prenatal Exposure to the Ukrainian Famine of 1932-33 on Adult Type 2 Diabetes. We have two speakers who are working on this subject and have presented earlier on it, and we're very excited to have them here as part of this focus on the Holodomor of these next 2 weeks. We're very grateful to Columbia Mailman School and Department of Epidemiology for being co-sponsors of today's event. Our speakers I will introduce them in turn before they speak, but the speakers are L.H. Lumey from Columbia University and Wolowyna from the University of North Carolina at Chapel Hill. First speaker will be Dr. Wolowyna, who has a licenciado degree in mathematics from the National University of Buenos Aires in Argentina, a master's in sociology from the University of Florida, a PhD in demography from Brown University, and who was a postdoctoral fellow at the University of Wisconsin in Madison. He is a fellow at the Center for Slavic, Eurasian, and Eastern European Studies at the University of North Carolina, Chapel Hill, and a two-time recipient of a Fulbright Scholarship grant in Ukraine. He's working on the 1932-34 famine in Ukraine and Russia with demographers at the Ptucha Institute of Demography and Social Sciences of the National Academy of Sciences of Ukraine. He's the co-author of several articles on the topic, and one of his articles received the ASN Gutenbach Prize for the best article published in the journal Nationalities Papers in 2020. Dr. Wolowyna is also director of the Center for Demographic and Socioeconomic Research on Ukrainians in the United States at the Shevchenko Scientific Society in New York. His latest publication is Atlas of Ukrainians in the United States, which we have copies available here if you'd like to pick one up. So please welcome Dr. Oleh.
So this is a project that we started some time ago because of its complexity. As you can see, it's a team project. We have 3 epidemiologists and 2 demographers working together because this combination demography and epidemiology. So I will present the demographic part, which is the underpinning for the epidemiological research that Dr. Lumey has been sparing, and he's an expert on this topic. In recent years, more and more people have been studying the long-term effect of the Holodomor, not just the short-term effect, how many people died, but we have demographic effect, population loss, the distortion of the age-sex pyramid. You can see the indentation because of birth loss. We have a very interesting article in Political Sciences. A person at York University did a study how people voted in different elections that went through the Holodomor, and it's really a fascinating study. We have psychological studies with behavior of survivors, how it affected them and their psychology, and the topic of today, that increased probability of type 2 diabetes. So the premise that we're looking at is that exposure to extreme famine during pregnancy increases the occurrence of diabetes type 2 later in life. So what are the elements that we need to address? First, we need to have death during the Holodomor, where we have to figure out how many died, where, what was the intensity of the famine, and we need a control of areas of Ukraine that were not affected by the famine. Then we need the birth of these women that were exposed to increased famine. And again, we need to see where they died, what time, and we need to have information of their birth before the famine, during the famine, and after the famine, and again, the control. And finally, we need to have a database of people that have diabetes, so we can link the birth with the diabetes and eventually the famine. So we'll go through each of these elements. First of all, we need a definition of death caused by a famine. And there are two ways to go about it. One is you look at the cause of death, and in some cases it's obvious that the person died of famine, but in many cases it's not easy to determine because you can have multiple causes of death interacting. That's one problem. The other is that, especially in Ukraine, in rural areas, especially during the Holodomor, where you have a tremendous amount of deaths occurring almost every day, there was no specialist to determine what was the cause of death. And we examined many death certificates. Most of them have no answer to the question cause of death. So for all these reasons, the cause of death definition, it does not work. But both demographers, epidemiologists, people that study famine, pandemics, came up with a concept of excess death. And that is, we estimate the total number of deaths, and then we estimate the number of expected deaths had there been no famine, and the difference between those two numbers is considered the number of deaths caused by the famine. The same concept was done to estimate deaths due to the pandemic, COVID-19. The same principle is well accepted, the concept of excess deaths, and that's what we're using in our estimation of Holodomor deaths. Now, in order to come up with all these elements that we saw in the first slide, the death, the birth, we apply what is called the population reconstruction methodology. So we start with census 1926. There was an urban count in 31, was a census 1937, and a census in 1939. And we had these 3 years in the middle, which were the famine years. And how to go about it? We used a so-called demographic balancing equation. You have population at year T, you add the total number of births during that year, minus total number of deaths that year, plus the number of net migrants, and you get the population next year. So that's how we do step by step by estimating births, deaths, and net migrants, and we proceed with the population reconstruction. We'll get into the detail a bit later. The first step of population reconstruction is you evaluate all the information and you figure out what needs to be adjusted because the information had problems. We start with the censuses. The 26 and 37 census were fairly well done, required minor adjustments, no big problem. 1939 census was falsified. Because what happened? Stalin had very optimistic projections of population growing tremendously, everybody happy, economy growing. The 37 census came and showed a drastic number of deaths. So much so that the population of Ukraine in 1937 was lower in 1926, although the population was growing at a very fast rate. This was a shock to Stalin. So he decided the census was no good, made it invalid, closed access to the data, but the country needs census. So they plan to have a census 2 years later in 1939, but now they have time to come up with a scheme to falsify the data because they knew they would still show the big hole. So miracles never cease. The plan of falsification of the 39 census was discovered in the archives of Moscow. It was sitting there. So we had access to the raw data and the plan, how it was falsified, and we were able to adjust the 39 census. For Ukraine, we lowered down 2.6%, and rural areas 3.6%. So those are the censuses. Birth and death, in every biostatistic system, even today in the United States, there's some under registration. Some births get lost. Some death get lost. In the case of the Holodomor, there was a tremendous amount of registration, especially in 1933. We'll see that later. So we had to estimate the under-registration of births and deaths and adjust accordingly. And there was no integrated system of migration, so we had to do it piecemeal, different migration streams. So once we have all that together, this is an example of the underestimation of death in Ukraine between 27 and 38. In 1931, before, it was around 12% underregistration, which was normal for that time. But in 1932, it goes up to 19%, and in 1933, as you can see, more than half of all the actual deaths that occurred were not registered. Why? Because as we can see, starting in January of 33, there was an explosion of mortality in Ukraine, and the number of deaths was so huge the system could not cope with it. Here you have a family, somebody died, but the rest of the family was not strong enough even to walk, not to mention to go to the registrative office and register that death. In some cases, the whole family died. In some cases, the person doing registration died. They ran out of forms. They had to use normal paper. So that's why we have this tremendous under-registration of death in 1933. And then it goes down, and there's a slight increase in 23. That's a lesson that one should examine the quality of the data, because in 37, 38, there was so-called terror years that Stalin murdered a lot of people. In Ukraine, it was about 140,000, but they were not registered. So we had to add them to have a complete accounting of all the deaths. So once you have done this adjustment, you apply the demographic equation and you go year by year. Let's not look at this, but you come to 1937 census. If your estimation of the birth and death and then migration were correct, the number you get from the equation should match the number of 37 census. So the censuses serve as control of how well did you underestimate the birth and death and made the correction and the migration. So that's why the beauty of the concept of population reconstruction is gives you a structure that kind of gives you a check. If they don't match, you have to go back and reiterate until you get a match from the demographic equation and the the censuses that you made sure were as accurate as possible. Now, we are going to start looking at distribution of famine in the different oblasts of the country. And in order to do that, we need a concept of relative excess death. But first of all, now we have all the elements to estimate excess death. We have total death calculated by population reconstruction. Now we need the number of deaths had there been no famine. How do we go about it? There are two ways to do that. We look at the deaths before the famine, like 29, 20, 30, 31, and we fit a line to that trend and extend that line to 32, 33, 34, and that line gives us the number of expected deaths if death continues in that trend as before. The other possibility is we look at, take 1 year before the famine, like 31, 1 year after famine, 35, and interpolate and get the numbers in between. So these are the two ways of calculating that. Now, so we calculate the intensity of the famine by the different oblasts, current oblasts of Ukraine. And in order to compare we need the relative value, not the absolute value. The relative value is dividing the number of deaths by the median population of 1933, and that also is given by the population reconstruction. So the population reconstruction gives us all the elements, and now what we did was we divided, these are the oblasts of the former Soviet Ukraine. These are current oblasts. We divide them in 3 categories: significant, severe, and extreme. And we have a control Western Ukraine that did not belong to Soviet Union at that time. There was no famine. So that should be our standard. And now we come to what I was talking about, the explosion of mortality. In 1932, there was significant famine all over Ukraine. It was basically part of the pan-Soviet famine, also in some areas of Russia, although Ukraine had higher famine. But starting in January of 31, there's a surge of mortality. It goes to the June, reaches a peak, and then the new harvest comes in. So there's enough food go around, so mortality goes down. The question is, to give you some idea about the extent of that, if you look at the raw excess death in January and divide by the months where it was maximum, the number of deaths caused by the famine in 6 months increased 10 times. In Kyiv and Kharkiv increased 5 times. The excess death, not the total death, caused by the famine, in 6 months increased 14 times. To give you a better idea what this means, we calculated what is the average number of deaths per day per month. In January, there were 3,000 deaths per day caused by the famine. When 4, 9, 13, 19. In June, there were 28,000 deaths per day caused by the famine in Ukraine. And to give you a sense of perspective, the state of Texas had a population more or less like Ukraine at that time, 30 million, I'm sorry. Mm-hmm. And we looked at the COVID, had different peaks. And the largest peak was in the week of January 16, 2021. The total number of deaths that week was 7,000. The expected number of deaths, that had there been no COVID, was 4,000. So the difference, the excess death, that during that week in Texas, COVID caused about 3,000 deaths per week, equivalent to 400 per day. Compare 28,000 versus 400. It gives you some idea about the tremendous impact, and Bertie is going to elaborate on that. This concentration of death allows us to capture very well the impact of the famine on the diabetes that Bertie is going to talk about, because 90% of all the Holodomor deaths occurred in 33. And of those in 33, about 85% occurred in the first 6 months. This is a unique characteristic of Holodomor not found in any other man-made famine. Actually, a French historian, Alain Blum, said this is probably the most extreme famine in all of history of Europe, looking at those figures. Now, what caused this explosion of death? Well, Stalin made some decisions. First of all, made it impossible for people to travel looking for food. In 32, Ukrainian farmers started traveling to Russia, looking for food. There was food in Russia, bartering, taking your gold and precious things. And it became quite a large number. So Stalin said, that's enough, round them up, send them back to their village, close the border between Russia and Ukraine and Belarus. So that avenue was closed. Many farmers went to big cities in Ukraine, Kyiv, Kharkiv, Dnipropetrovsk. There was some food there because the government had rations for the working people. And the streets were littered with dead peasants dying of hunger. So they issued sort of passports for the urban population. So just like here today on campus, if you didn't have the passport, they would not allow you to the city. So the travel to the cities was closed. And finally, if you wanted to leave the village, you're part of the collective farm, you had to have a very special permit to be able to leave the village. So that was one set of rules, basically make it almost impossible to travel to look for food. The second measure, because the quota was not fulfilled in Ukraine, there was a deficit. So Stalin said there were cities of underground grain by these peasants that are hoarding the grain, stealing from the state. So they launched a campaign of literally thousands of brigades who were house to house looking for hidden grain. They checked the attic, they went to the garden with a big poke, see if they found something there. And we have testimonies of thousands of people, survivors, that said when they came to the house, whether they found grain or not, they took all of it. The food that people were saving to survive the winter, gone. And finally, in order to make up the unfulfilled grain quotas, this is only in Ukraine, they took the seeds that was supposed to be used for the next harvest, seed grain, and there was an emergency grain fund. Those funds were depleted. So peasants were trapped in the village, could not travel anywhere. In many cases, they took all the food, so they're condemned to a slow death, and that's what basically explains this explosion of mortality that you will not see in Russian regions, grain-growing regions. We did the analysis for comparison purposes. I will leave this for you, Bertie, to talk about. Just a couple more indicators about the tremendous impact of the Holodomor. This is life expectancy of birth. In other words, if certain mortality characteristics stay constant for several decades, this is the average number of years expected to live. Before the famine, in Ukraine, people lived on the average in the 40s, between like 42 and 48, depending male or female. But then you have 32, which plummets in 1933. The life expectancy for females is 7.2 years, and for males, 4.3. What does it mean? If the conditions of the famine in 1933 stayed the same for many decades, a person born in 1933 during the famine would live on the average female 7 and male 4 years. These are numbers not found almost anywhere in any other famines. They're so extreme. And finally, actually, I got this from an email from a financial analyst at, I think it was Lehman Brothers.
Sounds, but they went bankrupt.
Well, one of those big firms, but he was doing analysis of the COVID-19 impact on the stock market, and he stumbled upon these data and he sent them to me. He said, "Are these for real?" I checked. This is a true death rate of 5 different families: Holodomor, Ireland, North Korea, India, Bengal, and China. As you can see, by far the mortality of the Holodomor except the level of all these other famous famines. So this gives you another idea about the extreme level of famine of the Holodomor. So to conclude, we spent a fair amount of time collecting the most complete demographic data. Colleagues of mine went to Moscow archives a couple of times because the Soviets destroyed a lot of the data in Ukraine, but copies are still there in Moscow archives. Ukraine was famous for having the best demographic data in all the Soviet Union. This time I'll explain that. And the methodology of population construction allows us to do all the necessary demographic analysis that is needed by the epidemiologist to do the analysis of the relationship between the famine and the diabetes type 2. Thank you.
Thank you very much, Oleh. Our next speaker, Dr. L.H. Lumey, studied medicine at the universities of Leiden and Amsterdam in the Netherlands, and history and philosophy of science at Darwin College, University of Cambridge, England. He was awarded a Fulbright Fellowship to study at Columbia University, where he obtained MPH and PhD degrees in epidemiology. Over the last decades, Dr. Lumey carried out a number of single and multi-generation cohort studies worldwide to investigate the relation between maternal nutrition and pregnancy and health outcomes in the offspring. These studies include men and women exposed to malnutrition during the Ukrainian famine of 1932-33, the Dutch famine of 1944-45, and the Chinese famine of 1959-61. Dr. Lumey is professor of epidemiology at the Mailman School of Public Health, Columbia University Medical Center.
Thank you very much for your introduction. Let me first ask, how much time do we have? Okay, very good. Well, thanks for coming here, making it through security also. I should emphasize that 99% of the work that founds this report was done by Oleh and his demographers. We're just doing the last 1%, analyzing data. And the 99% of the work is not just to look at the mortality, look at the births, these are data that we need, but also to do it in a setting that is extraordinarily special from a epidemiology perspective. Because epidemiologists are always saying, okay, you have something going on. What would have been the outcome if you had no exposure, if you had no event, you're always looking for control groups. And in control groups, you can say, I gave you an example. If you read in a newspaper about a study that people who have breakfast, they live longer. And epidemiologists would say, okay, do the people who have breakfast, are they comparable to the people who do not have breakfast? In other words, is having the breakfast the thing that drives longevity? Or is one person more health conscious than the other? But the people who do not skip breakfast, do they also go to a gym or do all kinds of other exercises? And in observational studies, the way we call it, it's extremely difficult to have a control group that is the same as the people you're examining in all relevant other respects. And especially in population studies, this is nearly impossible. So from the outside, the situation in Ukraine is extremely unusual because you have a very well-defined famine, beginning and end, concentrated in a very short period of time, with a very extreme exposure, with little migration between the exposed and the non-exposed, and good records. So from the exposure side, you have a very well-defined population. On the outcome side, you have to find some health outcome that is collected for everyone, that shows little bias, to make sure that the people who were exposed are not more likely to be diagnosed with diabetes. And this is available from the diabetes registry in Ukraine, where especially the people who are on insulin medication for diabetes are very motivated to be registered, because the government will provide the insulin at no cost to them. So the registry is a relatively very good outcome indicator. The other thing about the diabetes registry is that there are many, many studies going not related to the Ukraine, who have made a correlation between early life nutrition in infants born during a famine, after a famine, and later obesity and more diabetes. These studies have been going on 20 or 30 years, and the problem is that there had never been a solid control group for these types of outcomes. A lot of people who are extremely convinced that there must be a relation between the early nutrition as a risk factor because of the development of the fetus, all kinds of biological changes occurring during gestation that could be bad for your health and lead to more obesity, and more obesity, more diabetes. So I was extremely skeptical, mistrustful about all these studies, because we do not have reliable control groups. And as I've started studies in Holland and in China related to the famine, where we have some settings where we can compare women exposed to famine and having their babies, women giving birth before and after the famine, following their babies to age 50 and 60, and seeing if the babies were more likely to have diabetes or not, and then have estimates of what the excess risk may be. So these are studies maybe of 1,000 people, and in China a little larger, but the exposures are a little less well defined. So to me, the Ukraine situation was about as good as you could get from a technical laboratory point of view to identify the exposure, the famine exposure, and make a very plausible link with the outcome. So it's an extremely unusual situation. If the exposure is well defined in terms of severity, and if the outcome is well defined in terms of diabetes, and if the intermediate events in life as people grow up do not lead to changes in behavior, say if men and women born during the famine have a different childhood and their parents are so concerned that they affect their nutrition to a large extent, that in itself may affect their health outcomes later. All right, so we did a very primitive study many years, several years before, taking into account, I can skip these things. So this is all to make it very good from an epidemiology point of view. A very simple study where we had estimates of excess mortality, not by methods that Oleh described, but from other measures. And we were able to relate in 9 oblasts, the outcome with the diabetes exposure. I should specify the measures of excess mortality were taken from the national census in 2008, I believe. 2001. 2001, okay. So what do? We go to the census, not me, but colleagues in Ukraine. You say, I want to register, classify in these 9 oblasts the number of people in the census who were born in between 1930 and 1938. What is the number that was born there? So these are the survivors of the famine. Then I match this with the number of people who were in the diabetes register in 2008, who are also the survivors. And if the number of people that are in the census are a true reflection of the number of people that were born, then I can have a relative risk of what the impact of the famine does on diabetes. So I don't have the number of births, but I have the number of people who are in the census in 2010. So that gives me some sense of how large were the groups in these various oblasts that generate the diabetes cases, and what is the relative risk, if I count the diabetes cases in the oblasts, each of the oblasts, what is the relative risk of people having diabetes given the population size in that oblast? Let's see, I'll skip that. So we have 9 oblasts in the census. We had some intensity classifications: exposed, not exposed, medium exposed, and the population at risk estimated from the survivors. That gives us some idea of an excess diabetes risk of about 50%. And of course, this would be extremely important if it were really true, because we would have made a link between events around the time of the birth and health outcomes 70 years later. And people in medicine are extremely interested in the long-term impact and possible sensitive periods in human development. And to say, what is the period where the fetus is very sensitive to the outside world, and what can we prevent? Especially since in these studies, we identify the early period of gestation, the period early in pregnancy, the first 3 months, as a sensitive period, meaning that children who were exposed early in gestation would show a diabetes effect, but children exposed later in gestation would not show an effect, suggesting that once the fetus has grown and developed a little in the womb, then the effect in the development would be small. The effect in the growth would be there because the individuals would have a lower birth weight, but it wouldn't affect the potential of the fetus. Oleh talked about that, so I don't have to worry about that. So for the new study, Oleh gave us, based on the estimates of the excess mortality, a classification of current oblasts divided in non-famine, medium famine, severe famine, extreme famine, based on the excess mortality in these oblasts. So we say, well, since we have the data of the entire country, we can do the study again based on excess mortality classification. And we can match then the number of diabetes patients registered in the national data, not just in 9 oblasts, but over the entire country. So our study design includes then the entire country. The outcome are the diabetes cases. I don't think this shows. 128,000 over that period. The population at risk is now defined by the cohort reconstructions. So we have 10 million people, 10 million births between 1930 and 1938, divided between births in non-famine, Western Oblast, medium famine, severe famine, and extreme famine. And once we classify that, we get this table. So all his work boils down to this table, and the findings I present are just based on a simple analysis of what's going on here. So the table shows for men and for women, first of all his data, the number of births in the first half year of 1930, the second half year of 1930, 1931, 32, all the way out to 1938. So we have for all these years, first 6 months, second 6 months, the number of births for men, for women, in oblasts with extreme, severe, significant, and no famine. In the women, the same. So for the extreme, the births in the extreme areas in men, 700,000, 2 million in the severe, 1 million in the significant, no famine, 1 million too. If you add up these numbers, you get 10 million births divided in all these groups. And then we have, from the diabetes registry, we have the number of people born in each of these 6-month periods, in each of these years, in the register. For 400 for this month, 400 for this, all the way going out, adding up to 128,000 births. So in essence, we are looking if in a specific time period, the proportion of diabetes people out of the proportion of births, the proportion of diabetes people in 2008 out of the number of births in 1933 went up or not? Are people in a certain birth year, in certain oblasts, more likely to have diabetes later in life than others? And when we do more analysis, it turns out that the people in these columns, the first 6 months of 1934, are relatively more likely to have diabetes in 2008 than people born in any of the other years in any of the other oblasts. How do we do that? We're looking at a 2x2 table where we have the number of exposed. In each of the cells, we look at the number of exposed and the number of non-exposed. So exposed would be born in 1934. The number of non-exposed born in any of the other years. And here we have the number of people with diabetes and the number of people without diabetes. So you can imagine, once you decide that 1934 is your group, this would be the number of people with diabetes, this the number of people without diabetes in the exposed. And then if you add all these numbers and all these numbers, meaning this total number minus the births in 1934, you get the number of diabetes cases born in 94, the number at risk in 34, and then for the non-exposed, the number born in all the other years compared to the diabetes in all the other years. So if you do that, saying the odds among the exposed is then 100 with the disease and 900 without the disease. So the odds is this ratio. And among the non-exposed, you have 50 with the disease and 950 without the disease. In that case, the odds among the unexposed will be like this. And if you divide these, the ratio is about 2. So this is maybe I should feedback and see if this makes sense to you. You're comparing proportions in exposed and unexposed groups to get an excess relative to the controls. So this is a very basic epidemiology tool that you can apply to this big table. Does that seem to make sense? This is like a
Maybe the next graph will help.
So this calculation is applied to the table. The table has births in 1930, first half year, second half year, 1931, the same all the way out to 1938. So we have here cell 1, cell 2, all the way up to 1938. The table has the oblasts with extreme, severe, significant, and no famine in these colors. And if you calculate the odds in each of these cells, this bubbles around unity, no change. And this bubbles around unity at a higher level. But for births in the first half year of 1934, we get this crazy peak of the odds going up. And the peak is the highest in people born in the extreme severity oblast and a little higher in, highest in extreme, then second in severe, 3 in significant, and hardly affected in no famine. So this is a signal. We have 8 years, 30, 38 is 9 years, 8 years, 30, 31, 32, 33, 34, 35, 36, 37, 38, 9 years, 4 levels of exposure, that is 36 cells, first half year, second half year, 72 cells. So doing the same calculation in 72 cells, these 4 cells for the births in 1934 jump out. So something happened there that is crazy from an epi point of view. But from a historical point of view, these births coincide with the famine exposure. So there are 2 ways of analyzing these data with odds ratios. So they all come to show a twofold risk, a twofold odds ratio after famine exposure. The first analysis is to look at within birth regions. So we only examine the extreme exposure birth regions and calculate the odds ratio for those born in 34 first half to others. And then the odds is twofold. If we only examine severe, only examine significant, we get the same effect. If we only examine no famine, the odds are around 1, meaning that the famine effect in the famine regions is not seen in the control group, because in the control group, the odds are flat. This is similar to saying that in the control, the no famine group, it just bubbles around and it doesn't go up like this. Oh, going backwards. So that is within separating all of the regions to show that there is not something going on in the no exposure regions. And you can aggregate the effect for births in any of the famine regions. Here we see that the estimated odds ratio in the extreme exposure regions is about twofold, in severe also twofold, in significant 1.5, and in the aggregate 1.8. So this, from an epidemiology point of view, is also a very interesting observation that strengthens the inference, because you want a dose response. The more famine, the more likely the outcome is affected in the long term. And if there's no famine, there should be no outcome change in the long term. You can be a little more involved from an epidemiology point of view, and that is by using the no famine births as a reference. So in the previous analysis, we only examined our outcomes within severity exposure. Now we put everything together and we say the reference population for all of these comparisons is the diabetes prevalence in the no famine group. And the outcomes are extremely similar, with a 2.2 increase, with extreme and severe famine having very comparable outcomes, and significant famine, a little lower outcomes. So in summary, we find a twofold increase. Consistent findings that regardless of whether you examine within oblasts or whether you examine across all oblasts. And one way to illustrate this is to do exactly the same calculation for every oblast. So the bubbles show the calculation for every oblast separately. The larger group is the Western Ukraine, no famine, Kyiv, and I forget some of the abbreviations, but they're under. And what we see is that by and large, okay, so we have the excess mortality as from the calculations, ranging between 50 to 200 per thousand. Here we have the odds ratios that are, one is nothing going on, 1.52. And we basically see that the yellow dots in the middle are, the red and the yellow dots are about the same, elevated in a very similar fashion. So we would not be able to tell the difference between the yellow and the red dots in outcomes, because these outcomes are very similar. They're about the same distance away from unity. The green ones are a little lower, significant famine, and Western Ukraine is lower still. So these are for all the oblasts, the individual outcomes. And if we draw a line, weighting the population size in each of the oblasts, we get a very consistent relation between famine exposure in 1932, 33, and diabetes outcome later. So we show a twofold increase. It's related to famine exposure in early gestation. I haven't elaborated on that, but the only thing we know is that we can identify the time period, which births were the births associated with the higher diabetes 60 years later, 70 years later. And these were the births early in 1934. And from the historical pattern, we know that these are the births who were early in gestation in 1933, because the exposure itself was not the highest in 34, but it's the exposure that occurred 6 months earlier when the babies were in very early gestation. And we show a dose response. So epidemiologists like the control group before and after, they like the dose response, they like the timing, and they like that the magnitude of the effect, the twofold increase, is consistent with what is known from other studies. We're not saying this is a 10-fold risk or a 100-fold risk. That would be biologically very strange. Now, the limitation of the study is that we are comparing two time points. We're comparing the famine situation at the time of birth with the diabetes situation in 2008. And we don't know what's happened in between. So we are saying this is very suggestive. The correlation with the prenatal events is extremely high. But there could also be postnatal factors. So the debate now is whether the postnatal factors could be so strong that irrespective or in combination with the prenatal factors, they could cause a twofold increase in diabetes. And we're developing some of the pros and cons for that discussion. I think biologically, most people would say that they cannot think of postnatal nutrition changes that could bring that about. And you see, Oleh has several articles about social changes, coping strategies in families who were exposed to the famine to attest to whether or not, how were they reared? What is their memory of the famine? They may vote differently, there may have been a political impact, but did they also, are their nutrition habits different? And is there anything to that effect that could explain the differences? So that's the debate that we're having at the moment. I think from an epi point of view, the data are extremely suggestive and in a way quite shocking, because sometimes we think that the mother can totally protect the child in gestation, but there are other many studies showing that the mother should not smoke when she's pregnant, right, and not drink when she's pregnant, not have specific infections while she's pregnant, because the child can be like develop deafness or something. these are very specific examples of that. The mother is not absolutely protective of her unborn baby, and that you have to try and avoid these specific exposures at specific times. From an embryology point of view, this is pinpointing the timing of the exposure, saying that the early period, the first 3 months of gestation, is probably the most sensitive period when the fetus is still developing and maybe more sensitive to developmental changes that could play out in the long run. So the laboratory people are interested in this because of the timing. The epidemiology people are interested in this because it supports their notion about long-term impact of diabetes. And of course, there's definitely a political side to this as well, indicating that these types of man-made famines not only have a direct impact, but could carry on 60 years down the road. So I'll leave it at this, and if you have any questions, we should talk about them.
Thank you. Thank you so much for both of you for walking us through this, your methodology and how you got to these conclusions, to your results and to your conclusions. Very illuminating, and thanks for taking the time to do this. Any questions from the audience, and seeing if there's anything online? Any questions to our speakers? Yes.
Yes, I was wondering if there was resource we could look at to see this data at the oblast level. So say if I wanted to look at the statistics for effects in Luhansk Oblast or Donetsk Oblast, is there a place where I can look at that sort of data?
I can give you a link to the database. Give me your email. Yeah, for sure.
Yeah, I'll write it down right now.
I wonder, I'm sure the numbers would be so small that it wouldn't affect your data at all, but did you consider in this research people who survived the famine but emigrated, they were managed to leave the Soviet Union, whether in various countries? How is there any possible way of saying how diabetes would show up in somebody who was born in 34 that ended up, having diabetes in Chicago or in Melbourne, places like that? But I assume the numbers would be so small compared to what you're doing. But
This is an immigration question.
yeah, that's right.
Well, I wonder how complete are the databases on diabetes in these different countries.
Mhm.
It would be difficult to gather that data together because, as you point out, small numbers. So I can see significant difficulties there.
Mhm.
At least in Ukraine, you have a core.
Right, and that's what makes it such an attractive case model, as you were saying, right? Because it was basically because of the political situation, you had people that were not moving anywhere.
Right.
So as a test case, it's quite fascinating, I think, in that way.
Well, on the emigration, I think there are two components. The first component I think we saw, because the initial study looked at survivors in the census as a population at risk. We now look at the births, so that's your baseline. That's the baseline to compare the rates. For diabetes, you could do, I've done very limited studies on this, but maybe in future publications, you could say, what distortions of diabetes outcomes would you need to generate these outcomes? You would have to say that births in the first half of 1934 were were they more or less likely to emigrate compared to other births in order to generate this difference? And I think it would have to be, in order to get a positive effect, there would have to be spuriously high diabetes cases in this group, artificially high, which could emerge from more emigrations in all the other years, or from people in this birth year being more likely to be in the registry.
Mhm.
So then I would, I don't think people would be in the registry more likely to be cancelled by their date of birth being second half year 1932 and not 1933. So you would have to think maybe of administrative artifacts that make it more likely that people from a specific birth year ending up as having diabetes. And also, not only in the extreme exposure oblasts, but to a lesser extent in all the other oblasts. So there's a time effect. And sometimes we see time effects in epidemiology when, for instance, the registration of diseases changes, and then you go like this, and then whoop, suddenly it goes like that. A change of coding, a change of this, a coding of that. But for us, it would then have to be change of coding, whoop, and then a back change of coding, whoop, and then. So the things I think is worth exploring, but I'm not sleepless yet about that. But it would be better to do some calculations and to show a what if scenario leads to things that people would not believe.
Thank you. Thanks for your answer. Yes, please.
So first, just to make sure that I understand and my follow-up question isn't totally spurious. You're only looking at survivors in 2008 who are on the diabetes registry, then, correct?
Yes.
Do you think that there's reason to suspect that exposure to severe famine, especially increased mortality, such that like people who had diabetes at some point in their lives have passed away and were no longer on the registries at that point, and that therefore the effect is still being undercounted in some way?
That's totally possible. But I would think biologically that is plausible, but then you would have to find some evidence that people with diabetes, yes, are more likely to die, which is true, but you'd have to show that specifically for that group. But that's certainly an argument to say it's a likely undercount if the exposure leads to, we know that the famine exposure in other countries can lead to a 10% excess mortality. But if this is from diabetes, is complicated, because you could make the argument, as you say, that we are probably undercounting, but it's probably the best to do that on the basis of total mortality, because otherwise you get into problems that you could have excess deaths, but were they really from diabetes or not? And many people with diabetes die of cardiovascular type diseases. So what you say is extremely true, but we haven't made an argument yet that it's possibly an undercount.
How is something, are there any plans to conduct a similar study for people on another disease, using the same kind of methodology, or is diabetes kind of unique because of the registry?
Well, you answered your question. You'd have to find a condition that is evenly registered at the end of life across oblasts. Maybe the only condition that I can think of is mortality.
Yeah. But this is somewhat related. Is it true, Bertie, that the Holodomor study has shown the highest blood ratio among all the other families?
The order of magnitude is similar, 1.5. This
But
is
we're
two,
talking about
this is 2.2.
2.2.
So it's definitely higher, but it's the same order of magnitude.
Okay. So statistically, there's no difference.
I wouldn't say that, but the we're averaging out. So we have 4 categories of exposure in the oblast, but within each oblast there'll be variation in the individuals for famine exposure. So it's in the aggregate. We're saying in the aggregate, men are taller than women, but not all men are taller than women. Or not all men are taller than all women. So it's a very simple, general statement. But would you otherwise think that we should look at mortality? Or would that be simple?
Well, we can.
You'd have to look at deaths between 1938, 34, and now, every year.
Well, we have data by month, which is highly unusual.
Are there life tables for births in different oblasts?
Yes, they are.
So that would be the most comprehensive.
I was going to make a comment that it has been accepted in the Soviet Union that the data in Ukraine was the best in the 20s, 30s. There's a history behind that. Something that is almost unknown. The first histodemography created in Europe was in Ukraine. In 1918, in the middle of the revolutionary wars. And here's this government that is fighting the war on different fronts, decides to start Academy of Sciences, and they created the Institute of Demography, headed by Stucha, a well-known recognized demographer in Europe. And what is even more fascinating, that you have the statistical entity in charge of collecting the data and analyzing it, and then you have the institute, the theoretical demographers. But they understood the importance of collaborating between theory and practice. So they worked as a team. So the theoretical demographers worked with the people collecting the data or designing the surveys and the system and the censuses. And that joint effort created data that was extremely well put together, very high quality given the times. Afterwards, when the famine, the data shows the impact of the famine, then Stalin took care of that. The KGB took over the statistics and they started manipulating the data. But before, up to, and during the Holodomor, they was damn good, except for the under-registration. And that's why we were able to do this very detailed analysis. And as Corey points out, more can be done because we do have the data that almost no famine has, because this happy circumstance, historical circumstance.
Fascinating. Thank you. Any more questions? Yes,
Yeah.
please.
You spoke briefly about how you had colleagues access the archives in Russia.
Yes.
Could you just speak a bit more to what that process looked like? Did you contract out to a team, or how did it go?
No. What happened is that, after Perestroika, There was high demands to access the data because the archives were closed for many years. They opened in the late 1980s. So Western researchers were anxious to get into the archives and dig into the data. So people in Moscow and the archives realized, hey, we're out of business. So they gave people access, but they charge you a very high premium for every page that they zero of the original. So we took advantage of that. Twice my colleagues, in both cases females, went to Moscow and came with a list. And we had to wait, and then they came back and we managed to get most of the data, not only for Ukraine, but for Russia as well. With two exceptions. There is the Northern Caucasus cry, that within that, there's some areas very heavily populated by Ukrainians, and they're suffered as much during the Holodomor as in Ukraine. The level of mortality is just as high there. And then there are a couple of okruga in the border between Ukraine and the Kharkiv area that also has a high concentration of Ukrainians. They gave us everything except data for those two areas. Said, can't find them. Turns out then another historian that has been working with the Russians for quite a while got that data. And it took us years to have that data finally available. So now we have complete data, not only for Ukraine, but for Russia. So we can, and we did a comparison and an economist, a team also did a more econometric study. And the conclusion is that in terms of level of famine in Russia, the single most important factor is to prevent Ukrainians in certain areas, being statistically documented. Now, the second trip.
Does that speak to intent?
I'm sorry?
We're now looking at the Trump thing, and the lawyers say we have to prove intent. Does this speak to targeting?
Well,
in your point of view?
I think that if we can elaborate on what caused the surge of mortality by just the measures taken by Stalin, you can talk about intent. And there's a lot of quotes that, you know, Ukraine is in danger, we cannot lose Ukraine, exploitation of the drain potential of Ukraine
No, but
for the whole Soviet Union.
I'm thinking of these enclaves. What does that show to the question?
Right now, this is correlation,
Okay.
econometrics. But we do have, especially in the Northern Caucasus, where the tremendous amount of persecution, whole villages were emptied out, wiped out, literally. So there was actually there was a movement of they allowed Ukrainian culture to flourish for a while, but then, according to Stalin, went overboard. So they closed that because it was hijacked by Petroliucci, by nationalists, by enemies. So this is more historical type of argument. But to finish the story about the archive, the second trip, if you remember what happened in January 2014, Maidan. Two female demographers went to Moscow, checked into the hotel, went to Red Square, and opened the Ukrainian flag. And they came back alive. That was the second trip to and last to the archives. But I guess we can say mission accomplished.
All right. Well, if there are no more questions. I'd like to thank you for coming and for your questions, and thank you so much to our speakers for this fascinating.
Well, I think
description
the
of your
audience
work.
should be commended.
For
Yes,
making it to our talk.
I thank them firsthand. But no, but this is very important. And it's again, next week, we're also focusing on this extraordinary period of time for
Yeah.
Ukraine. So thank you so much for getting the ball rolling as we look back 90 years or so into this very important period that is connected with today's Ukraine as you've shown us. So thank you very much.
Okay. If you don't have that information, please help yourself. This is a different topic about Ukrainians in the United States. Official Bureau of Census Statistics.
Yeah, those.